Continuity and differentiability. See here, first I'll give definition of continuous function. A function f of x is said to be continuous. At x is equal to a if limit extends to a, f of x must be equal to f of a. The function f of x is said to be continuous at a point x is equal to a if limit extends to a, f of x must be equal to f of a. See here, this is a condition of continuity. What does it mean here? Limit extends to a, f of x is equal to f of a means I can write that is the limit value of f of x at x is equal to a must be equal to function value of f of x at x is equal to a. Limit value of f of x at x is equal to a is equal to function value of f of x at x is equal to a. Then only I can say that function f of x is continuous at the point x is equal to a. Here see, when that limit value exists, we know that limit value of this function exists if and only if left hand limit is equal to right hand limit. Limit value of that function exists if and only if left hand limit is equal to right hand limit, that is limit extends to a minus f of x must be equal to limit extends to a plus f of x. If LHL is equal to RHL, left hand limit is equal to right hand limit at that point a, then I can say that the limit value of that function exists. If that limit value exists and is equal to function value f of a, then I can say that function is continuous at x is equal to a. See here, I will give different examples regarding this topic. See, first of all, see example 1. See, general meaning of continuity means a function is continuous means it must be a continuous curve without any breaks. The general meaning. The function is said to be continuous that at any point means it is a continuous curve without any break. See here, suppose this is my function f of x defined, let us say, in between a and b. So in between a and b, I can say that my function f of x is continuous. F of x is continuous. Take any point in between a and b. Let us say this function. Let us say this is a point. Let us say point x1 on x-axis. For x1, see here, this is the corresponding point on the graph. There exists point on the graph for x1. So it is a continuous function, no break. Suppose if you take break here. See, let us say this is a point x2 on x-axis. See, for x2, there is no image on the graph. There is no image for x2 on the graph. So at x2, I can say that function f of x is discontinuous. At x2, that function f of x is discontinuous because it is the function has a break at this point. Like there is a break, empty space, no connection between these two curves. There is a break. So now I'll give examples of discontinuous functions, different discontinuous functions. Now see here, suppose function is like this. This is my function f of x. Here this small circle, empty circle, indicates that there is no connection between these two curves. That is empty space. Let us say the point x is equal to 2. Here the corresponding point is, let us say this is a 4. This is a solid point. Corresponding point is 6. Now see here, I can say that at x is equal to, so by seeing this graph I can say that at x is equal to my function f of x is discontinuous. By seeing graph I can say directly, because for x is equal to, see here function is like this. It is a see after reaching x here, see here it takes jump here, taking jump here. Again from this point, function is like this. So here function is like this, here up to 2 function is like this. So at x is equal to, what about function here? It is taking jump here, after again after 2 the function is again coming here and going down here. So I can say that at x is equal to, the function f of x is discontinuous. By seeing graph I can say directly. Now how can you say that function is discontinuous? Using definition. What I said, see definition here, limit extends to 2, f of x is equal to f of 2, then I can say that at x is equal to, my function f of x is continuous. It is applying definition. Now see, for this problem I will apply definition, I will apply definition and verify that whether it is continuous or not. See, what about limit value here? So first we find out limit value. Limit extends to, so to find limit value, first we need to go for left hand limit. Limit extends to 2 minus f of x. So left hand limit, when x is approaching 2 from left hand side, what about the corresponding function approaches to which value? 4. Similarly, what about right hand limit? When x is approaching 2 from right hand side, 2 plus means approaching 2 from right hand side, corresponding function approaches to again 4. So left hand limit, right hand limit both are existing and are equal to 4. So therefore I can confirm that limit value is 4. Limit extends to 2, f of x is equal to 4. Now what about function value? If you see the function value, f of 2, function value means exact value. At x is equal to 2, here see the function is a single point here. Graph is single point, that is 6, f of 2 6. See here limit value is existing and is equal to 4, but whereas function value also exists and is equal to 6, both are not equal. So limit value not equal to function value. Limit extends to 2, f of x not equal to f of 2. So while violating condition of continuity, therefore I can say that at x is equal to, the function f of x is discontinuous. F of x is discontinuous. That is using definition, discontinuous. If you know the graph, we can go for directly graph. By seeing graph I can say directly it is discontinuous. This is a second method, or you can go for definition like this also. There are 2 methods are there to check continuity. First method is using graph. Using graph I can say directly whether it is continuous or not. The second method is using definition. Using definition we can say that a given function is whether it is continuous or not. Now I will go for one more example. See here. Here my function is f of x. F of x is equal to x square minus 1 by x plus x minus 1. X minus 1, where x not equal to 1. Where x not equal to 1. Now see whether we have to check. My question here is function f of x continuous at x is equal to 1. Continuous at x is equal to 1 or not? We have to check this one. See here, if you see the limit value, first I will go for a definition. Limit extends to 1 f of x. Limit extends to 1. F of x is here x square minus 1 by x minus 1. That is equal to limit extends to 1. I can write this one as x plus 1 into x minus 1 by x minus 1. X minus 1 will get cancelled. 2. You will get limit value 2. But what about function value? F of 1. See here, f of 1 value does not exist. F of 1 value does not exist. F of 1 does not exist because here at x, the function is not defined at x is equal to 1. The function is not defined at x is equal to 1. Therefore, limit value is 2, whereas function value does not exist. Therefore, limit value not equal to function value. Therefore, I can say that given function is not continuous. Given function is not continuous at x is equal to 1. So, whenever given function is does not exist at any point, at that point the function is always discontinuous. It is given that x not equal to 1. If function does not take x1 means x not equal to 1, does not take x not equal to 1, x not equal to 1. So here the function is always discontinuous at that point. Okay, see here, if you take x is equal to 1 here, see here we will get 1 minus 1 by 1 minus 1, we will get 0 by 0 form, we will get undefined form. So at x is equal to 1, function is not defined. So I am eliminating that point here. Here we are checking continuity at x is equal to 1. Here function at x is equal to 1 not defined. So if it is not defined, always it is not continuous at that point. That is using definition. Now using graph, how can you say that that function is discontinuous? See here, using graph. See here, graph of that function will be like this. That function f of x is x square minus 1 by x minus 1. If you simplify this one, you will get x plus 1. So to get point on x axis, you have to put y0, that is f of x0. F of x0 means x plus 1 is equal to 0, x is equal to minus 1. So we will get minus 1 here. That x plus 1 is a linear function. So linear function means graph will be straight line. So it will be like this, passing through minus 1. And what about x? The function f of x is not defined for x is equal to 1. So at x is equal to 1, we will get empty space here, no graph. No graph. So by seeing graph, I can say directly at x is equal to 1, function is discontinuous. No graph, no image for the point x is equal to 1. So by seeing graph, I can say directly it is discontinuous. Or you can go for a definition like that also. Now we'll give one more example. Consider this function f of x 2x plus 3, x for x less than 0, 0 for x is equal to 0, x square minus 3 for x greater than 0. My question is f of x continuous at x is equal to 0? First I will go for a definition, after that I will go for graph. I said two methods. We can verify given function is whether it is continuous or not by applying two methods. First method definition, second method graph. So applying definition here, see what is the definition. We have to check this condition. Limit extends to 0, f of x is equal to f of 0. Then only I can say that at x is equal to 0, my function f of x is continuous. Now see here, finding limit value of f of x at x is equal to 0 is equal to function value of f of x at x is equal to 0. So first verifying that limit value. So to find limit value here, we have to go for left hand limit and right hand limit, because here the function defined for x less than 0 2x plus 3, for x greater than 0 x square minus 3. So first finding left hand limit is limit x tends to 0 minus means x less than 0. For x less than 0, the corresponding function is 2x plus 3. So we will get a left hand limit value 3. Right hand limit value, limit x tends to 0 plus means x greater than 0. When x greater than 0, the corresponding function is x square minus 3. So if we replace x with 0, we will get minus 3. So left hand limit, right hand limit both are existing, but not equal. Left hand limit not equal to right hand limit at x is equal to 0. Therefore I can say that limit x tends to 0, f of x value does not exist. Limit does not exist. If limit does not exist at x is equal to 0, I can say that function is discontinuous, because if limit exists and is equal to function value, then only I can say that At x is equal to 0, function is continuous. If limit does not exist, that is always discontinuous at that point. That is using definition. Now I'll go for graph. What about graph of that function? If you see the graph of that function, so 2x plus 3, 2x plus 3, 2x plus 3 for x less than 0. So that is a linear function. Linear function means that a graph of that function will be a straight line. So to get point on x-axis, we have to put y0. y0 means f of x 0. That is 2x plus 3 0. We'll get x is equal to minus 3 by 2. So somewhere we'll get a minus 3 by 2 point. So the graph passes through minus 3 by 2. Passes through minus 3 by 2. So here at x is equal to 0, here we'll get empty space, no graph here. At x is equal to 0, the function is 0. Here we'll get solid point. For x greater than 0, x square minus 3. So x square minus 3. So what is the graph of that x square minus 3? Parabola. So how to draw that graph x square minus 3? See here, to get point on y-axis, put x0. If you put x0 in that one, we will get corresponding point on y-axis. So putting x0, we will get minus 3. So we get here minus 1, minus 2, minus 3 somewhere. This is, let us say, minus 3 point, minus 3. So here we will get empty space. And what about point on x-axis? To get point on x-axis, we have to put y0. y0 means f of x0. f of x0 means x square minus 3 is equal to 0. X is equal to, we will get under root 3. So somewhere we will get under root 3 here. So the graph will be like this. So for x less than 0, straight line. At x is equal to 0, only single point graph. For x greater than 0, the graph will be parabola. So we want to check continuity at x is equal to 0. You see at x is equal to 0, see here the graph is not continuous. So graph is coming like this. Here at this point it is taking jump here. After that again here it's taking jump here. After that it is continuing like this. So by seeing graph I can say that at x is equal to 0, function f of x is not continuous or discontinuous. F of x is not continuous. See, by seeing graph we can generalize one thing here. If we draw any graph of the function without lifting pen or pencil, I can say that is continuous function. Otherwise it is not continuous. See here, can you draw this graph without lifting pen or pencil? See here, from this, start from here. After reaching here, you have to lift the pen. Again you have to come here. After this one, again you have to come here. After that you have to go like this. So without lifting pen or pencil, we can't draw this graph. So that is a discontinuous function. That is a general meaning of discontinuous function. If you draw any graph without lifting pen or pencil, that is a continuous function. Suppose you are lifting pen or pencil, that is not continuous. That is a discontinuous function. Next we will go for definition of differentiability. What is meant by differentiability? A function, I will give the definition. A function f of x is said to be differentiable. Is said to be differentiable, or I can say derivable. Differentiable at any point x is equal to a if limit extends to a f of x minus f of a by x minus a value exists. If this limit exists, limit of this function exists, then I can say that function f of x is differentiable at x is equal to a. Then I can say that if that limit exists, then I can say that will give f dash of x. That will give f dash of a. That is a derivative of that indicates derivative of f of x at x is equal to a. If that limit value exists, then it is denoted by f dash of a, that is derivative of f of x at x is equal to a. Now See here, what does it mean geometrically? Limit extends to a f of x minus f of a by x minus a exists. See here, f of x minus f of a by x minus a, that will give slope of f of x at x is equal to a. So what I am saying here, limit value exists. Limit value exists means limit is always unique. Limit value of any function is always unique. So limit is unique means I can say that the slope of this function f of x at x is equal to a is unique. I can say that the slope of that function f of x at x is equal to a is unique. Then I can say that in that case I can say that that function f of x is differentiable. If slope is not unique, that function is not differentiable. See here, for example, take any graph, take any function. Let us say this is f of x. My function is f of x. I want to check differentiability of this function. Let us say at x is equal to any point a. At x is equal to a, I want to check differentiability of that function f of x. Now see here, at x is equal to a, this is the corresponding point on the graph. At this point I can draw only one tangent to the curve. Only one tangent. Only one tangent to the curve. Nothing but, see here, I can see that the slope of the tangent at this point is unique. Slope of the tangent to the curve at this point is unique. Slope is unique means that a limit value is unique. Slope is unique means we will get that limit value is unique. If limit value is unique, at that point I can say that given function f of x is differentiable. Otherwise it is not differentiable. See here, otherwise means I will give one more example so that the function not differentiable. Suppose if you take a graph like this, this is my function f of x. Let's say this is the corresponding point a on x-axis. Now, if you see here for x is equal to a, this is the corresponding point on the graph. At this point here, if you draw a tangent to the curve, it will be like this. You can draw more than one tangent. You can draw infinite number of tangents at this point x is equal to a. That is more than one tangent is possible. If more than one tangent is possible, the slope of the tangent is not unique. That is f of x minus f of a by x minus a. That is not unique. Slope of tangent is not unique. If slope is not unique, the function is not differentiable at that point. Therefore, here at x is equal to a, the function f of x is not differentiable. Not differentiable. At x is equal to a, the function f of x is not differentiable. Not only this point, here also not differentiable. More than one tangent is possible. Slope not unique. Here also more than one tangent. Whenever, see here endpoints also. To take endpoints also, we can draw more than one tangent. Slope not unique, so not differentiable. Here also more than one tangent. So if you take that smooth curve, for smooth curve also, if you take n points, at n points you can draw more than one tangent for smooth curve. So I can say that smooth curve is always differentiable except at n points. Because at n points you can draw more than one tangent, slope is not unique. So at that points, at that n points, the given function is not differentiable. Whenever given function has a sharp edges like this, sharp edges or corner points, or suppose sometimes given function may have like this this is called a cusp. So here also function is not differentiable at this point. Whenever given function has a sharp edges, corner points like this cusp, for all at all these points given function is not differentiable. If you take any smooth curve is always differentiable at every point. At every point it is differentiable except at endpoints. So why? Because see, take any point on the smooth curve, we can draw only one tangent. Any point on the smooth curve, only one tangent is possible, like this. So this is a definition of differentiability. Now we'll do problems on continuity and differentiability. First problem, at x is equal to 0, the function f of y is equal to mod x is option A continuous but not differentiable, continuous and differentiable, not continuous but differentiable, not continuous, not differentiable. So here y is equal to, the given function is y is equal to mod x. So first I said we can check continuity and differentiability by applying two methods, definition one method and graphical method, second method. So suppose if you go for graphical method, see what about graph of that function y is equal to mod x, it will be like this. See here first we will go for that method 1, graphical method. The graph of y is equal to mod x will be like this. This is x axis, this is y axis. So regarding continuity, we want to check that whether given function is continuous or not at x is equal to 0. So this is the point x is equal to 0. So at x is equal to 0, it is a continuous function. No break at x is equal to 0. It is a continuous curve without break at x is equal to 0. Therefore, by seeing graph, I can say that at x is equal to 0, at x is equal to 0, function y is equal to mod x is continuous. Mod x is continuous. Now checking differentiability. Checking differentiability. Now see here at x is equal to 0, the given function has a sharp edge. Sharp edge means you can draw more than one tangent. More than one tangent is nothing but that slope is not unique. Slope is not unique means limit does not exist. Limit does not exist means not that limit does not exist means not differentiable at that point. So I can say that at x is equal to 0, y is equal to mod x is not differentiable because the given function has a sharp edge at this point, not differentiable. So the correct option is continuous but not differentiable. That is option A is correct. Continuous but not differentiable. That is using graph. Now using another method, that is a definition. How can you say that given function is continuous but not differentiable? Using definition. So if you apply definition, see here. First checking continuity at x is equal to 0, checking continuity. So to check continuity, we have to check this condition. Limit x tends to 0, f of x is equal to f of 0. If this condition satisfied, then I can say that given function is continuous at x is equal to 0. Otherwise, not continuous. Now, see here, to check this condition, first we have to find out limit value. So to find limit value, you have to find out left hand limit, right hand limit. If left hand limit, right hand limit both exist and are equal to same number, then only that limit value exists. See here, what about left hand limit here? Left hand limit is limit x tends to 0 minus means x less than 0 mod x. So when x less than 0, what is the mod x value? We know that minus x means we will get minus 0 means 0 only. That is left hand limit value. Similarly, right hand limit. What is the right hand limit? Limit x tends to 0 plus means x value greater than 0. When x greater than 0, mod x value is plus x only. When x greater than 0, mod x value is plus x. Since mod x definition is mod x is equal to x for x greater than or equal to 0, that is equal to minus x for x less than 0. So left hand limit 0, right hand limit 0, both are equal. Therefore, I can confirm that limit value is 0. Limit x tends to 0, f of x value, that is the mod x value is 0. Limit value 0. Now see what about function value? Function value means you have to find out f of 0. F of 0, what is f of 0 value? F of 0 is modulus of 0. Modulus of 0 is 0 only. Therefore, limit value exists and is equal to 0. Limit value 0, function value also 0. Both are equal. Therefore, that condition of continuity is satisfied. Limit value 0, function value 0. Therefore, given function is continuous at x is equal to 0. Therefore, I can say that at x is equal to 0, I can say that the function f of x is continuous. that is using definition. Now I will prove that function is not differentiable. Already we know that function is not differentiable at x is equal to 0. Not differentiable at x is equal to 0. I will prove this one using definition also. Now differentiability at x is equal to 0 for this one, for the same function. So to check differentiability, we have to find this here. We have to check this limit value. Limit x tends to 0, f of x minus f of 0 by x minus 0. So what about this limit value? Whether this limit exists or not, we have to check. If this limit exists, then I can say that the function is differentiable. Otherwise, not differentiable. So to check whether this limit exists or not, again you have to go for a left hand derivative and right hand derivative. What is left hand derivative here? Limit x tends to 0 minus f of x minus f of 0 by x minus 0. That is left hand derivative, we can say that here. So limit x tends to 0 minus f of x. 0 minus means x less than 0. When x less than 0, what is our f of x? When x less than 0, f of x is minus x minus f of 0 value 0 by x. So we get minus x by plus x, that is equal to minus 1. So we got left hand derivative value minus 1. Now that right hand derivative is limit x tends to 0 plus nothing but x value greater than 0, f of x minus f of 0 by x minus 0, that is equal to limit x tends to 0 plus, when x greater than 0, f of x value is x, so we get x minus 0 by x, that is equal to x by x, that is equal to 1. So here left hand derivative value minus 1, whereas right hand derivative value plus 1. So left hand derivative not equal to right hand derivative. At this point x is equal to 0, at x is equal to 0, left hand derivative not equal to right hand derivative. Therefore, I can say that function is not differentiable at x is equal to 0. So that limit value does not exist. When that limit value exists, I said limit must be unique. Limit must be unique, nothing but left hand derivative equal to right hand derivative. If left hand derivative equal to right hand derivative, then only I can say limit is unique. Otherwise, limit is not unique. Here, limit is not unique here. Minus 1 plus 1. Two different limits we are getting here. Limit is not unique. I said that if limit is not unique, we can draw more than one tangent. So, for this function at x is equal to 0, we can draw more than one tangent. So, slope is not unique. Slope is not unique. Therefore, at x is equal to 0, the given function f of x is not differentiable. So, the correct answer is continuous but not differentiable. Like this, we can do every problem in two ways, using graphical method, using definition. See that second question, the function y is equal to modulus of 2 minus 3x. Option A is continuous for all x belongs to R. X belongs to R means for all x belongs to real numbers, set of real numbers, and differentiable for all x belongs to R. Option B, continuous for all x belongs to R, differentiable for all x belongs to R, except at x is equal to 3 by 2. Continuous for all x belongs to R, differentiable for all x belongs to R, except at x is equal to 2 by 3. Option D, continuous for all x belongs to R, except at x is equal to 3, and differentiable for all x belongs to R. See here, if you know the graph, it is better to go for graph. By using graph, I can say by using graph, it is very easy to check whether the given function is continuous or differentiable. See here, what is the graph of this function? Since it is a simple function, y is equal to modulus of 2 minus 3x. Since it is a simple function, it is better to go for graph. What is the graph of this function? See here, graph. See, to get point on x-axis, we have to put y0. So if you take y0 here, so you will get x value 3 by 2. X value, sorry, put y0, you will get see here 2 by 3. Somewhere we will get here 2 by 3. X is equal to 2 by 3. So now, since it is a modulus function, modulus of 2 minus 3x. So graph will be like this. X-axis, y-axis. So the graph of y is equal to mod 2 minus 3x. So it is a continuous function. It is a continuous function, no breaking point at all. It will go like this continuously. It will go like this continuously. It is a continuous function. So the given function is continuous for all x belongs to R. For all x belongs to R, it is a continuous function. Now, what about differentiability? See, is it differentiable at every point? No. Why? Because see, at x is equal to 2 by 3, the given function has a sharp edge. Sharp edge. Whenever given function has sharp edge, at that sharp edge, given function is not differentiable. So at x is equal to 2 by 3, the function is not differentiable. At x is equal to 2 by 3, the function f of x is not differentiable because it has a sharp edge at this point. Therefore, the given function is a continuous for all x belongs to R, differentiable for all x belongs to R, except at x is equal to 2 by 3. So that is option C is correct. Next question. This question given in grade 13. Which one of the following function is continuous at x is equal to 3? See, option A, B, C, D are given. So let's check one by one. First we will go through option A. Here option A is given that f of x is equal to 2 if x is equal to 3, x minus 1 if x greater than 3, x less than 3, for x less than 3, x plus 3 by 3. So to check continuity here, so first we have to find out limit value. Limit value at x is equal to 3 is equal to function value at x is equal to 3. Then I can say that given function is continuous. What about limit x tends to 3 f of x value, first limit value. So to find that limit value, first we have to find out left hand limit and right hand limit. That left hand limit here, left hand limit is limit x tends to 3 minus means x less than 3. When x less than 3, the corresponding function is x plus 3 by 3. So the corresponding left hand limit value replacing x with 3. So 3 plus 3, 6 by 3 will get 2. Similarly, right hand limit, see that right hand limit x tends to 3 plus means x value greater than 3. So when x greater than 3, the corresponding function is x minus 1. Replacing x with 3, you will get corresponding RHL value 2. So left hand limit exists, right hand limit exists, and both are equal. Therefore, I can confirm that limit value is 2. Limit x tends to 3, f of x value is 2, limit value 2. And what about function value? Given function values here, for x is equal to 3, the corresponding function value is 2. So that is f of 3 value 2, that is given in the problem. Therefore, limit value exists and is equal to 2. Function value also 2. So limit value is equal to function value at x is equal to 3. Therefore, the given function is continuous at x is equal to 3. So that is option A is correct. If option A is correct, then what about option B, C, D must be wrong. So we will check that one also. See, option B is, what is option B here? F of x 4 if x is equal to 3, 8 minus x if x not equal to 3. So if option A is correct means option B, C, D must be wrong. Wrong means option B, C, D are discontinuous functions at x is equal to 3. Option B, C, D must be discontinuous functions at x is equal to 3. See here, why it is discontinuous at x is equal to 3? See that corresponding function value is 4 here. Function value of that f of x at x is equal to 3 is 4. What about limit values here? You see the limit value here, 8 minus 3, 5 will get. So limit value 5 whereas function value 4. Limit value not equal to function value. Therefore, given function is not continuous at x is equal to 3. Similarly, check option C also. Option C is f of x is equal to x plus 3 for x less than or equal to 3, x minus 4 if x greater than 3. See here, if we, what about here limit value? See here, to find limit value, first we have to go for left hand limit or right hand limit. What is left hand limit for x less than 3? X plus 3 function. So the left hand limit value is 3 plus 3 will get 6. What about right hand limit for x greater than 3? Right hand limit is 3 minus 4, that will give minus 1. So here left hand limit is 6 whereas right hand limit is minus 1. Left hand limit not equal to right hand limit, therefore limit does not exist. At x is equal to 3, limit does not exist. If limit does not exist, the function is not continuous at x is equal to 3. So Option C also discontinuous function at x is equal to 3. Now see that option D here, f of x is 1 by x cube minus 27 if x not equal to 3. So see here, at x is equal to 3, see here, suppose if you take x is equal to 3, what about that 1 by 3 cube minus 27? You will get 27 minus 27, 0, 1 by 0, you will get infinite value. So at x is equal to 3, the function is not defined, you will get infinite value. So function does not exist at x is equal to 3. So function value does not exist, then at that point given function is always discontinuous, because function value does not exist. Whatever may be the limit value, function value does not exist. At that point given function is discontinuous, because that is violating condition of continuity, limit value not equal to function value. Therefore, except option A, all remaining BCD are discontinuous functions at x is equal to 3.